Yes, today we shall see what do you mean by resolution of vector into components. Okay, for that I'm taking a real-time scenario. Let's assume a box is being pushed by a man. I'll name this person A towards my right. So how do I represent it in coordinate system? Of course, pushing is a force. Say he's pushing with 10 Newton force. This is my vector. So how do I represent it? I represent this vector with an arrow proportionately. Say this is 10 Newton and this is my vector F, and I write my vector as 10 into I cap. I cap is for positive x-axis. Next, same box now is pushed by the person, okay, towards say away from us. So let the force be 10 Newton again. How do you represent it in the coordinate system? Now the coordinate system is, the force on this coordinate system is along positive y-axis. So vector F, say this is 10 Newton, and I will represent this as F is equal to 10 J cap. J cap is for positive y-axis. Now let's say the same box is now pushed by two people, person A as well as person B. So person A pushes it in the direction of a positive x-axis and person B pushes it with some force away from us. So how do you represent these two forces? Well, more than representing these two forces, what if I say the box moves in a direction which is a result of two pushes from person A as well as person B. Now I will say this is 10 Newton. Then 10 Newton of force is contributed by person A as well as person B. How to calculate precisely what is the contribution of person A and what is the contribution of person B? If we are able to calculate that, what are we doing it here? We are doing the components of the force. Got it? So now this force of 10 Newton is made up of two components. One is contribution of person A along x-axis. I will call it as x component of the force, plus contribution of person B. I will call it as y component of the force. So here Fx and Fy are called components of F. This is true for any vector, maybe displacement vector, velocity vector, acceleration vector, any vector in general. If it is a three-dimensional vector, vector A, then it will have three components: Ax along x coordinate, Ay along y coordinate, Az along z coordinate with a k cap. Okay. Today let us focus only in two-dimensional vector. So again I am taking x-axis and y-axis, and here is our force. Okay, to calculate precisely how much is the x component of force and how much is the y component of force out of this 10 Newton, I will need one extra information. What is the angle made by this vector with x-axis? Suppose let's say it is 30 degree. Okay, now what I'll do here is I will just drop a perpendicular, and I drop a perpendicular here. So what I get in this direction is, here's my green, this is person A, green, this is person B, pink. Okay, so the quantity here, the physical quantity on the x direction, this gives us force on along x-axis, and this part is nothing but force along y direction, y-axis. Okay, so to calculate this is adjacent side of the right angle triangle here. Therefore, to calculate fx, I can take cos function. So cos theta, okay, bye bye, I will close it, bye. Cos theta equal to adjacent fx by hypotenuse f. So fx equal to f into cos theta. So f is 10 Newton, cos of 30, which is cos 30 is root 3 by 2. This is 5 root 3. See, now I know contribution of person A along x direction is 5 root 3 Newton. Similarly, to calculate Fy, I have this opposite side here. So we will take the sine function. Sine theta equal to, okay, opposite, which is Fy by hypotenuse f. Fy is equal to f sine theta, which is 10 times sine theta is sine 30, which is 1 over 2, which is 5 Newton. So we have got our y component as well. Now I can say this 10 Newton force is made up of, right, this 10 Newton force is made up of something into I cap plus something into j cap. What is this something? X component fx, this something is y component fy. So f equal to 5 root 3 I cap plus 5 j cap. Look at here. In terms of magnitude of the force and the angle, I have got the x component formula. So it is also called horizontal component, and this is called vertical component. Fy is equal to f sine theta. So there is an interesting point to observe here. So here is our force. This is fx equal to f cos theta. This part is fy is equal to f sine theta. If you apply Pythagoras theorem, square of the magnitude of force should be equal to sum of the squares of other two sides. Let's verify. F square is equal to fx square plus fy square. Pythagoras theorem. Does it come true? Of course it will come true. Let's see quickly. So f cos theta whole square plus f sine theta whole square, which is f square common, cos square theta plus sine square theta. Now you have, this is your favorite identity, cos square theta plus sine square theta is equal to 1, right? So we got f square is equal to f square. Also f is equal to, therefore we can write magnitude of the force equal to x component of the square plus y component whole square under square root. Okay, in general I would recommend magnitude of any vector. oops, my markers are very bad. Magnitude of any vector is equal to square root of x component square plus y component square. Okay, this is what we follow throughout this chapter. Okay, what if there is one more component? Of course, add z component square too. But remember, when it comes to two-dimensional vector, x component is fx cos theta, y component is fy sin theta, but z component is not f tan theta. It's totally different. What happens in three-dimensional vector? It's a different ball game which I'm going to teach you in next class. So for now, let us solve a problem. So for a problem, I would go like this. Okay, find the components of velocity vector of a vehicle traveling at speed say 80 meter per second due, let me give a random direction, 30 degree from negative y-axis. Ooh, it is not very familiar to us, but we can always draw. So we know our coordinate system. My markers. So my coordinate system is here. This is negative y-axis. So I have a velocity vector of the vehicle which is making 30 degree. Okay, now we know magnitude of velocity is given as 80 meter per second. What we need to find out? X component is equal to what? Y component is equal to what? For that we need the angle. Can we take the angle as 30 degree? No, we cannot, because see here, to apply fx equal to f cos theta, fy is equal to f sin theta, we have to make sure that angle made by the vector is with x-axis, but here 30 degree is not with x-axis. So what is the angle made by the vector, velocity vector with x-axis? This is negative 60 degree, right? Why negative? It is in the clockwise direction. The sign conventions what we follow is anti-clockwise positive, clockwise negative. So it is negative 60 degree. So we have theta equal to minus 60 degree. Okay, now we are good to go. So let's apply our formula. Vx equal to v cos theta and vy equal to v sin theta. So it is 80 meter per second cos of minus 60 degree. Cos of minus theta is cos theta, so 80 into cos 60 is 1 over 2, which is 40 meter per second. What is this? X component of velocity. Now y component of velocity, v is 80, sine of minus 60 degree, 80 into sine of minus 60 is, what is that, minus root 3 by 2. So it is negative 40 root 3 meter per second. So velocity vector of the vehicle is along x, it is 40 meter per second. So 40 I cap plus of minus 40 root 3 j cap, right? That is because v is equal to vx I cap plus vy j cap. This is our standard representation. Okay, So we got our velocity vector to be 40 I cap minus 40 root 3 j cap. See, where exactly is the vector? Vector is in the fourth quadrant. Fourth quadrant, you have positive x, negative y. Positive x, negative y. Perfect. So if you have, in case, in any other problem or in any other scenario, if you have a vector somewhere here, what would you expect your vector to be? Suppose A is a vector. What would you expect your to be? Something into minus I cap plus something into positive y axis. So j cap. It would look like minus something I cap plus something j cap. Yeah, good. All right. So where do we actually